All right, here we go. We are going to review 5.4 to 5.6. Like I said, the 5.4 section is the greatest common factor. And I only put, well, let's see. I shouldn't say that. Yeah, I think I can say that. That there's only one where you have to find the greatest common factor. All right, and it looks something like this. This is not the exact problem, but it's pretty close to the same problem. This one's actually a little harder than the one on the quiz. So I've got 63 x cubed y squared plus 81 x, oh, sorry, it's supposed to be an x, what is it, 39, x squared y to the fourth, x squared y to the fourth. And the question says just a factor. It's all it says. So you have a whole section. So on the quiz, the factoring starts at 14 and goes to 20. All right, so 1 through 13 is all the stuff that we covered yesterday. So 14 to 20 is all factoring. Okay. What is that, the first what? Y? Is it squared? I don't know. Let me see. Yeah, it is. I did say squared, and I didn't write squared, did I? Thank you. All right, so there it is. So there's a problem. Very similar to this on the test. Not exactly the same numbers, but it's pretty close if you can do this. So what we want to do is find out what is the largest number that divides evenly into 63 and 81. Any idea? 9. That's right. 9 goes into both of them. All right? 9 goes into both of them. 9 goes into, well, let's just put a 9 right there. We'll figure out how many times it goes into it in a second. All right, so 9 goes into 63 and 9 goes into 81. That's the largest number that divides evenly into those numbers. All right, what about the x's? X cubed, x squared. What's in common with both of them? An x squared. It's not a 2. It's an x squared. All right, now I got y squared, y to the fourth. What goes evenly into both of those? Y squared. All right, that's your greatest common factor. But it doesn't say just find the greatest common factor. All right, it says to do what? Factor. And we want to factor it completely. All right, so we found the greatest common factor, but we got to find what is being multiplied by this in order to get this whole thing right here. So how do we do that? We do the opposite of distributive property, which instead of multiplying, we what? Divide to figure out what's in here. So we're going to take this first one right here, and we're basically dividing it by 9x squared y squared. All right, so let's do it one at a time. 63 divided by 9. So what times 9? 7, right? All right, and then x cubed divided by x squared. It's just x. And then y squared divided by y squared is 1. 1 times x is x, and then you're done. Well, with that part anyway. Plus, there's no y because y squared divided by y squared is 1. It's the number 1. And 1's being multiplied by this, so you don't really need the 1 there. So the y's, they kind of cancel out if you want to think of it that way. All right? You can go to the office. I can let you go to the office. But give me a pass. I need a pass. Still in school. Use that. All right, here we go. It's 81 divided by 9. What's 81 divided by 9? It's 9. All right, and then x squared divided by x squared, it's 1. Y to the fourth divided by y squared is y squared. Remember, it's not an x. It's not a 9x. X squared divided by x squared, x squared divided by x squared is 1. It's the number 1. I got it. Thought I had it. Not yet. I keep putting them in different pockets and I forget which pocket I put them in. I got so many pockets. Did you put your name on there? Put your name on there. What's that say?
Office. I was rushing.
Okay.
I wouldn't be able to do that.
All right, and that's it right there. Okay, that's greatest common factor. So you only have one type of those on there. Again, this is 39 from section 5.4 if you wanted to look it up. All right. All right, let's see what else we got. Let's do one of these. This is a difference of two squares. I think we did difference of two squares in 5.5. So let me find a problem from 5.5 with a basic. It's not going to be a real complicated difference of two squares. Let me find one. Where are they? Oh, I'm on the wrong. No wonder. I'm on the wrong section. 5.5. All right, let's do this one. Here we go. This is from section 5.5. Which one was I going to do? That one right there, 25. This is number 25. So it's 81 a to the fourth minus 49b squared. And again, every one of these problems is under the factor. So I say factor, then I have a whole bunch of problems underneath of it, and that means you factor all those problems. So I'm not going to write factor every single time. So this is number 25 from section 5.5 if you want to go back and look. All right, you got to recognize that there's no greatest common factor. Is there anything in common with 81 and 49? There's nothing. All right, there's nothing in common with A and B. So you got to have another way to do this. And this is a difference of two squares. Here's your difference, which means minus. And both of these things are being squared. You are squaring something to get both of these things right here. All right? So on a difference of two squares, hopefully you remember that you need to put your two sets of parentheses. One is plus, one is minus. And they're going to be the exact same things in both of those parentheses, except for the signs in the middle. All right? All the stuff here and here are going to be the same with both of them. So what you have to do is figure out what times what is 81 a to the fourth. So what times what is 81? What times itself? I shouldn't say just what times what. What times itself? 9, right. And then what times itself is a to the fourth? A squared, good. So basically what you're doing is you're kind of taking the square root of that. Not kind of, exactly. You're exactly taking the square root of this to figure out what goes here. Now, if the other parentheses is exactly the same as this one, then what goes in the first one here? 9a squared. Now, when I say exactly, the plus and the minus are different, but everything else is exactly. All right? Do the same thing with this one. What's squared, or what times itself is 49? 7. And then what? It's a weird 7. 7b. And then you put the same thing there, and you're done. It's as easy as that. And the problem on the test is just as easy. In fact, it's probably even a little easier, to tell you the truth, the one on the test, than that one. Any questions on that? Difference of two squares. You got to recognize it. Recognize that it is a difference of two squares. This is a perfect square minus, then you can do that. Is there a sum of two squares? There's no sum of two squares, but there is a sum of two cubes. Okay, there is a sum of two cubes. And let me see what the next problem is. It might be that. It is. There's a sum of two cubes. So let me find one in the book. There we go. This is 5.5, yes. 52, number 52 on 5.5 looks pretty close to the one that's on the test. And again, I think this one's a little harder than the one on the test. So the one on the test, so far anyway, have been a little bit easier than what I'm showing you. So I guess that's good. You would rather it that way, wouldn't you? Than me do an easy one here and then you give a hard one on the test. All right, and then plus 125y cubed. Plus 125y cubed. All right, first thing I want to do is recognize it. That's the key to doing a lot of these factoring. Recognize what kind of factoring is it. I don't write on there, it's this particular kind of factoring. All right? So let's do it. What I want to do is recognize that it is a sum of two cubes, which means it's something cubed plus something cubed. And I tell you what, let's write down the formula for it, and then we'll work on it. This is something you're going to have to memorize. If you don't have this memorized, you're going to have to memorize it. All right, so here's what we do. We put a parentheses, another parentheses, Second parentheses is always a little bit longer because I'm putting 3 things in the second parentheses. I'm only putting 2 things in the first parentheses. First thing I do is do my sign. Okay, figure out what the sign is. We learned a little way to do that. So look at that plus sign. So we always go same. Remember that? Same, what? Opposite, positive. So what's the same sign as this? It's plus. What's the opposite sign of this? It's minus. And what is this one? That's always positive. Okay? Now we got to figure out what's going to go in those blanks right there. I need to put something here and here. I need to put something in these 3 spots right there. So whatever is being cubed is going to go right here. So look at this. What's being cubed to give you 8? What number cubed is 8? It's a 2. Now this is a little tricky, but what is being cubed to give you x to the 6th? X squared, that's right. Because, watch, if I do this, 2 cubed is 8. X squared cubed. What's the rule for an exponent to another power? To multiply, right? 2 times 3 is 6, so 2x cubed. Or 2x squared, and then that's being cubed. Let's do the same thing over here. Now, it looks like a bigger number, but it's really not that hard. What is being cubed to give you 125? 5 is, that's right. You know it's not going to be anything else except something that ends in a 5, right? Because it's a 125. All right, so 5 is being cubed. What's being cubed to give you y? That's easy. It's just a y. So that whole thing is being cubed. That's what I would do first before I'd put any numbers into this little formula. Okay, this is what's being cubed, so that goes in your first spot right here. So this is 2x squared. What's being cubed to give you this? That's just a 5y. Should have given myself a little more room, but we'll squeeze it in. Now, what goes in this first one? It's not 2x squared. That's right. We have to square this, okay? So we look at the first one, and we square it, and we put it here. Okay, because if you remember, let's do this. I should have done this. I was going to do this here. In fact, you know what? I'm going to do it like I was going to, and I just forgot. I'm going to put the actual formula here. I should have done that. I was beginning to do it, but I didn't. So this is going to be x plus y. What goes here? X squared, and then y squared goes here. How do I find out what goes in the middle? What do I do to these two? I multiply them together, and I put an xy. So there's my general formula for this. All right. Now let's let it apply to this. So I'm going to give myself a little more room. All right. Same, opposite, positive. So right here, what goes here? 2x squared. What goes here? 5y. Now, what did we do to get to this? What did we do to this first number right here, that x, to get to this? We squared it. So what are we doing to this? We are squaring it and putting it here. So if I take 2 squared, what's 2 squared? 4. And then x squared squared. What is x squared squared? X to the 4th. That's right. All right, so it's 4x to the 4th. If you need to write it down off to the side, feel free to do it if you get confused. Most of you probably don't need to do that. All right, let's do the second one over here. The second one is the y that's squared. So it's this whole thing. We got to square that, or this right here. Square that whole thing. So it's 5 squared, which is 25, and then it's y squared, which is y squared. Now, what do we do to get the middle one? We took the x and the y and multiplied them together. So I take this and this, not just the x and the y, okay, but this whole thing and this whole thing, and multiply them together. Very easy. 2 times 5 is 10, and then what? X squared y. It's not cubed, this is a squared. We're taking this times this. So it's 2 times 5 is 10, x squared y. Goes right there, and that is your answer. Okay, looks a little weird, but that's your answer. If you wanted to, I wouldn't do it, okay, especially on a test, because time is of the essence on a test. You could take this and multiply it all out. You'll find out a whole bunch of stuff cancels, and you're going to eventually be left with this. So this right here equals this. And now it's factored. Everybody good? Yeah, pretty basic. If you know this thing right here, right? If you don't know that, you won't have a shot at this, right? If you don't know that thing right there, there's no way in the world you'll be able to get this answer. You just got to know this. Got to study it, all right? You got one more day to study. All right. Anyway, I won't say any more about that. Let's, factor by grouping this time. So let's find me a factor by grouping problem. I'm going to, this is still 5-5, still 5-5. I'm just going to do the example. It's sitting there right in front of me, so might as well do it. This is example 12. While I'm thinking about it, I know most of you probably won't do this, but I don't know, maybe you will. If you were not here for several of those days, which the majority of you were not, you're still responsible to learn the material that we went over those days. So where do you find that? You go to YouTube and you look it up, all right? You should be very grateful for that. I don't hear enough thank yous for putting this stuff on YouTube, and I should hear it all the time. Because if you're not here, you should be looking at the YouTube page. What other teacher have you ever had that does stuff like that? Nobody, all right? So here we go. We're factoring again. I'm not going to write the word factor. You know what we're doing with all of these. So this is x squared minus y squared. And it's plus x minus y. Plus x minus y. All right, this says factor by grouping. Because right here, can you find the greatest common factor? Is there a greatest common factor? Is there? For all four of them? Not for all four of them, there's not. Okay, so you can't do that. Is it a difference of two squares? No. Is it a difference or sum of two cubes? No. So there's got to be something else that we can do. Well, it kind of is difference of two squares. Do you see it in there? Yeah. See, there's the difference. There's the two squares. So what we're going to do is we're going to group them like this. Okay? So I can factor something out of this one. All right? So it's a difference of two squares, so let's do it. We've already done a difference of two squares. Let's do it again. Plus, don't forget that one right there. All right, so we're just grouping the two sets together. Remember difference of two squares? One's plus, one's minus. Take the square root of that, that's easy. X, take the square root of that, that's y. This is exactly the same thing, except one's an x and one's a y. Now, remember I said before you couldn't do a greatest common factor, but now we can. Look at this. Look at this term, and then look at this term. Do I have anything in common with both of those? Yeah, what do I got in common? X minus y. So let's factor out an x minus y. So if I take this whole thing right here, that whole term right there, and I divide out an x minus y, what am I left with? If I take out this x minus y, I'm left with an x plus y. Okay? And then, oh, wait a minute, what am I doing? Hang on a second. No. Oh, I got it. This. Yeah, that's what I want. Okay? Because I'm factoring out of this. So what am I left with? An x plus y, and then I put a plus here. If I factor out an x minus y from this, what am I left with? It's a 1, thank you. Right, take this divided by x minus y, and it's a 1. But we're going to write it a little bit nicer than that. Okay, that looks kind of messy. Actually, what did I just do? X, y. No, I'm good. I was looking at something else. I got x minus y times, and how do I write this without all these parentheses right there? Just put x plus y plus what? 1. And there you go. And now it's completely factored. Okay? So again, what did I do? I pulled out an x minus y right here. What's left over? X plus y, and then put a plus. Pull out an x minus y from this. What am I left with? Remember, it's division. X minus y divided by x minus y is 1. Put it here. Just clean it up a little bit without all these parentheses in the way. And that right there is factored. It's two things that are being multiplied together to get what we started with. Okay? Right? So this and this are equal to the same thing, but this is factored. It's something times something else, which equals this. Again, if I wanted to, I could distribute this, and then after I distribute everything, I'd be left with this problem right here. Okay? So you'll have one of those. Very similar to that. Um, okay, I put 2 of those. Oh, I put 3 of them. Oh, actually, this is a perfect square. So this one you should be able to recognize. All right, let me find one like that. This is 5, 6. No, yeah, it's 5, 6. Now, this is one that most of you were not here for, so you better watch the video. Does anybody watch that video before today that wasn't here the other day? You did? Okay.
What day was that? Like that?
One of them. Let me find. I'm trying to look for a good problem. Tell you what, I might just do an example. Hold on just a second. It's a special product problem. All right, I'm going to do like a little, since most of you weren't here for this, watch, I'm going to show you. This is like a little teaching. This is in the video. Guys, I haven't stopped. I don't know why. I take a half a second to breathe and you start talking already. So watch, I'm going to do a little teaching and I'll show you where this comes from since most of you weren't here when I did this. So this is a special product they call it, okay? Because look, it's the same thing, right? It's x plus 3 times x plus 3. It's the same exact thing. Let's see what we get. Let's distribute. So it's x times x, which is x squared. Then the outside is just a little FOIL method, plus 3x, plus the inside is 3x, and plus 9. All right? Let's see what we get. We get x squared plus 6x plus 9. All right. That's not really the question that's going to be on the test. The question on the test is going to be this. It's going to be, I'm going to give you this, and I'm going to ask you to do what to it? I'm going to ask you to factor it. So I want you to see something. If you take a look at this, if I took the square root of 9, what do I get? 3. Okay? Yes. I'm trying to think of how I explain this. Plus 2x, 3x, plus 2x. Well, let's do it like this. Let's do it like this because this is going to help us with some other problems. What I want to do is think this. What times what equals 9 and what plus what equals 6. All right? So, yeah, this is a really easy one, okay? So it's 3 times 3 is 9. And where do I get the 9? This one right here. Where did I get the 6? This middle one. Okay, so I want to find out what times something. Now, they don't necessarily have to, you'll see in the next problem, they don't have to necessarily be the same number, okay? So I want to find out what times what is 9, but these same two numbers have to add up to be 6, and 3 is your number, isn't it? 3 and 3, all right? So if you have that situation, then what you can do is you can take this, put your parentheses here, put an x here and an x here, and what do I get? I got a plus 3, and I get a plus 3. This is the same as that. So I just wanted you to see where that came from, all right? Why that's true. So that's how you factor these things right here, okay? X squared plus 6x plus 9 factors to be x plus 3 times x plus 3. And that's the little trick, I guess. It's not really a trick, but it's the method, okay? We'll use that word. It's the method that we use to figure out how to factor it. So let's do another one like that. So you'll have one like that where it's a perfect square, okay? Where this and this are exactly the same. So you'll have one, and I'll even tell you what number it is. It's number 18 on the test. Number 18 on the test, okay, will be very similar. Actually, I won't give you all this stuff, okay? I'll give you this thing right here. It's already circled, okay? I'll give you that, and you got to turn it into that. All right. Sorry, confuse you on that one. You got 2 more to do. Let's do another one. Very similar to that, but they're not going to be exactly the same thing. Let me find a good one to do. There we go. Here's an easy one. This is an example as well. This is example 1 on section 5.6. So x squared minus 6x plus 8. This is an easy one, and I think I'll pick out a little harder one. We still got more than 10 minutes, so and we only got 2 problems to do. So I think it's good that we'll do a couple of these. All right, so it's going to say to factor. Said I wasn't going to write it every time, but I will. So again, what are we going to do? This is how I like to write it. I've watched a lot of videos of a lot of different people, different teachers teaching the method to do this. This is what I like the best. I've seen this one guy do it like this. To me, it makes the most sense. Other people are doing this like triangle thing or this X thing, and it's too confusing. I think this is about the easiest, most streamlined way to do this. So I want to find what number times what number equals what. Which number here am I looking at when I multiply them together? It's going to be 8. Those same 2 numbers, whatever those numbers are, now they don't have to be identical numbers, okay? But those same 2 numbers, if I add them together, they need to add up to be what? No, they multiply to be 8. They add up to be, that's not a 6, it's a negative 6. Okay? Everybody see that? So I got to think in my head. I got to do a little bit of mental math. This is where it's really nice to be able to know your multiplication tables. All right? These numbers are super easy. Everybody should know these. All right, so first of all, what do we got? What times what is 8? Well, 1 times 8. Is there any way I can get 1 and 8 to become a negative 6? No. What other number do I have? 2 and 4. Is there any way I can get a 2 and a 4 to become a 6? Absolutely, okay? That's if what?
You add the negative.
They both have to be what? They both have to be negative, okay? So negative 4 times negative 2 is positive 8. And remember, these 2 numbers have to be exactly the same as these 2 numbers. Negative 4 plus negative 2 add up to be negative 6. That's the work, okay? That's the part that you have to think about, all right? Sometimes they're harder than that. Those are pretty easy, okay? That one right there was pretty simple. Okay, there are some that are a little more difficult than that, but that's what you're going to do. So how does that help me? Well, it helps me a lot because those are the numbers that are going to go in here. What do I put first? This times this has to equal x squared, right? So what's going to go here? An x, because x times x is x squared. Remember, the last have to multiply to be 8. But I could have used 1 times 8, or I could have used 2 and 4. I could have used both positive. I would have been wrong on any of those cases. So what do I have to use here? A negative 4 and a what? Negative 2. So they multiply to be positive 8, and they add up to be negative 6. That's the key to this problem. That's the key to factoring these kind of problems, all right, is they multiply to be positive 8, and they add up to be negative 6. Let's do one more like this, because we're going to do the next one. What was that one, 18? Yeah. We're going to do one that's quite a bit more complicated for number 20, okay? So let's do another one that's kind of basically the same. Let me find one. Let me see. All right, just a regular old factoring problem. All right, let's do this one. X squared minus 12x, x squared minus 12x plus 35. Okay? This isn't that hard. It's probably no more difficult than the other one, but it's at least one more that we could do to practice this. All right, so what are we going to do? We're going to go what? And eventually, once you do these more often, and you were supposed to do these for homework, so everybody should have already done these, and I know how it works. Most of you did it. Some did. So what times what is what? No. Right, they multiply to be the last one. Remember, first and last, right, are multiplication. It's the outside and inside that add up. So the same 2 numbers, if I add them up, need to equal what?
12.
Negative 12. All right? Everybody see that? This is a little different than the other one because the other one, well, nope, it still is the same. Okay, still the same. It's no different. It's just different numbers is all it is. Yeah, what? 5 and 7, right? Because that's the only thing that is 35, right? I mean, 1 and 35. Is there any way you can get 1 and 35 to add up to be negative 12? No. So what are we going to use? Negative 5 and what? Negative 7. And then same thing here. So that does work, doesn't it? Once you figure that out, writing the answer is super easy. You just put your two sets of parentheses, all right? You've got your x, thank you. Yep, and then minus 5 minus 7. Minus 5 minus 7, and there you go. It is factored. If you wanted to check it, you could always FOIL method, see if it comes back to what you started with. It will, if you did it right. There you go. No biggie. Everybody good? Yeah, the one on the test, pretty much like what we just did, okay? Let's do another one. We got 8 minutes. So this one, the leading coefficient was what? What was the coefficient in front of that x squared? It was a 1, okay? Those are fairly easy, okay, when your coefficient is a 1 out in front of it. It gets a little more complicated when this is another number besides 1, all right? And that's what we're going to do right now, all right? So let me find a good one. Let me see. I don't want to get too complicated. All right, here we go. Let's do this one. I'm going to go 4x squared. This is from one of the examples. Oh, actually, we can't do that one. Forget that. Let's find one that we can do. Let's find a good one. Yeah, let's do this one. Yeah, this is a good one. Here we go. So let's go 3x squared. 3x squared minus 4x minus 4. Minus 4x minus 4. All right, here we go. This is it. This is the last 7 minutes. Last 7 minutes of new stuff. Not new, well, for some of you it's new, but it's the last 7 minutes of me teaching you. All right, so let's use that and pay attention. Here we go. The coefficient in front of here is not a 1, isn't it? Okay, so what we're going to do is this. Okay, everybody watch. What I'm going to do is take the first one and the last one, and I'm just going to show you the steps. I'm not going to show you like why or anything. I'm just going to show you how to do it, all right? Just so you can get it right on a test. That's the only reason I'm doing this right now. So I'm going to multiply those together. What happens when I multiply those together? I get what? Nope. Nope. It's negative 12. Okay, you got to look at the sign before. Okay, we always forget about that. I don't know why. Always look at the sign before. It's 3 times what? Negative 4, which is negative 12. So, nope, I'm just taking those numbers. See, the arrow just goes to the 3 and it goes to the 4. So I'm taking 3 times negative 4, which is negative 12. Now I'm going to apply that same rule that I did earlier. Okay, I'm going to go what number times what number equals negative 12. And I'm going to take those same two numbers, add them up. What do you think I want them to equal when I add them up? The middle one, which is negative 4. Okay, so now we have to do a little thinking. What times what is going to give us this? So 1 times 12. So it's always a possibility, but will 1 times 12 or 1 plus 12 give you a 4 or 1 minus 12, any combination? No. What about 3 times 4? 3 times 4 is 12. Okay, 3 times 4, that's a common one. When we think of 12, we always think of 3 times 4, don't you? But is 3 times 4 going to give us a negative 4 no matter how I add or subtract it? No. Noah, what number did you think of? 2 and 6, that's right. Okay, and he said positive 2 and negative 6. Does that add up to negative 4? Yes. Do those same exact numbers multiply to be negative 12? Yes, they do. So that's the key to that problem right there. Okay, the 2 and the negative 6. It's x. So what I want to do is do something a little different than I did before. So for some of you, this is the first time you've ever seen this. You need to go back and watch when I taught this, because I do a few of these problems, all right? But watch what we do. I'm going to take this minus 4, and I'm going to do this by grouping. I'll show you what I'm going to do. I'm going to write 3x squared, and what I'm going to do, instead of writing negative 4x, I'm going to write it as positive 2x minus 6x. I'll show you why in a second. Now, would you agree that this, what I wrote down, is exactly this problem? Yeah, because 2x minus 6x is negative 4x. All right? Does everybody see that? Now, problem is, well, on this one, definitely, I don't want the 2 to go first. Because what I'm going to do is I'm going to For the first two, I want something in common. Actually, no, I don't want to do that. I want to put the 6 here. Let me just double check, make sure that they do that. I didn't do the problem, so let me just check to see how they do it. 3p plus 2, or 3x plus 2 minus 2. Yeah. Okay, let's do it like this. I could also write it like this. 3x squared minus 6x plus 2x minus 4. Would you agree that's the same thing? Guys, this is not the time. Yeah. Give me like 3 minutes. It's 3 minutes. So look, let's take a look at this. What I'm going to do is I'm going to group it. Do you see why I did it this way? Because look, I got a 3 and a 6 in common. I got an x and an x in common. Right here, I only had the x in common. Okay? So I'm going to write it like this. We've already done a grouping problem today. So let's do it one more time. So what's in common? What's greatest common factor with both of these? 3x. Let's find out what's left over. 3x squared divided by 3x is x. 6x divided by 3x is what? 2, right? Plus, what's in common with this? 2. So I factor out the 2, I get x what? Minus 2. Now, let's take a look. This is that grouping thing. And that's the whole reason why we split that negative 4x into this. So we could end up with what we have right here. So what's in common with both of these? An x minus 2. Let's figure out what's left over. If I take an x minus 2 out of this, what am I left with? 3x. Put a plus. What if I take an x minus 2 out of this? What am I left with? A plus 2. And now it's factored. If I wanted to, and you could if you wanted to, you could distribute it and see if it ends up the same way. Let's do it real quick. X times 3x is what? 3x squared. Then the outside is plus 2x. The inside is minus 6x. The last is minus 4. Sure enough, 3x squared minus 4x minus 4. That's what we started with, isn't it? All right? And this is what we ended up with. This is the factored form of this problem right here. That'll probably be the hardest problem on the whole test. All right? What's that? 1. Number 20. This is number 20. All right? And don't just say, well, it's only one problem. I'll just get it wrong. No big deal. All right? I mean, come on. Try to get everything right. All right? It's your last chance. Some of you guys are looking at your senior year the wrong way. I mean, it's too late for me to give this talk. I've given you this talk before. But you guys are looking at your senior year the wrong way. You shouldn't look at it. We've talked about this. You shouldn't look at it. I'm still talking. We shouldn't look at it.
He's still talking. Yo, keep going, man, bro. Don't even do that. I didn't do anything. Yes, you did, bro.
I'm done.